Another day, another problem. So let's solve it. Hello guys, I hope you are all doing well. Today in this video we will solve the problem longest increasing subsequence. So a subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. So the question gives us an array of integers and they ask us to return the length of the longest increasing substring in this array. So let's say we have a list of number and the return gonna be also a list of integer but only that have the longest increasing subsequence, and you also notice that those numbers are not adjacent. So the first way to solve this problem is using dynamic programming, and that's what I'm gonna show you today in this video. The next video I'm gonna show you how to solve it using multiple methods. So as we know guys, dynamic programming is to break a bunch of smaller sub-problems and solve the large problem. So we're gonna create an array that have the same size of the input array, and at each index I of this length array, we're going to store the length of the longest increasing subsequence that we can form, with the last number of that increasing subsequence being the number at index I. Let me show you guys how we're gonna solve it. So for this example, we have this number of list. We create an array called length. So the first index, we're going to store the length of the longest increasing subsequence that we can get starting at the first index. For example, we have 10 at index 0. The second array that we're gonna build is going to be index of the numbers that come before. For example, the index 3 at number 5. In the first array, we're gonna store the number length of the longest increase. And the second array, we're gonna store the index of what comes before these numbers. And after that, we start iterating throughout the input array. We have the number 9 is 10 smaller than 9, and so we cannot put 10 before 9. So we add 1, and for the second array, put none, because there is no number that comes before 9. So we update the length list and also the indices list. So now that you get the idea of how to solve this problem, we don't need to repeat the same process again and again. Why not create a DP array that's gonna have the same length of the input array, and at each value inside it gonna be 1 at first. And after each iteration means we find the longest, update the DP array that have the length of the increasing longest substring. Let me show you how it's gonna be done with another example. So we have an input list 2508. We create a DP array that will have the same size of input array, and all the value gonna be 1, means the longest increasing subsequence for each number. For 2 gonna be 1, for 5 gonna be 1, for 0 1, and for 8 gonna be 1. After that, we create indices array that's gonna have the index that comes before each longest increase at each iteration using I. So let's start at 2. 2 has no numbers before, means we put none in the indices array. The array that have the longest increasing subsequence means the length, we keep 1. For the second number, which is 5, the previous number is 2, and 5 is bigger than 2, so we add the index of number inside the index list, which means 0, and we update the length of the longest increasing subsequence to be 1 plus 1, because we have 2 numbers inside the list now. And we move to the next number, which is 0. Is 0 bigger than 2? No. Is 0 bigger than 5? Also no. So we add none to the indices array because there is no number before 0 inside the list. And we don't update the length of the list, we keep it 1 because 0 have only 1 length. We move to the next number. 8. Is 8 bigger than 2? Yes. So we store the index of that number that come before, which is at first gonna be 0. And after that, we're gonna update the length of array of the longest increasing subsequence to 1 plus 1. And we check also is 8 bigger than the number 5? Also yes. So we update the indices to the previous number of 8, which is now 5. So index 1 and, instead of 0. So we update the length of the longest increasing substring to 2 plus 1. And if we compare 0 and 8, which have the length of 2, compare it to 2 and 5 and 8, which have the length of 3, we take the longest length of the longest increasing subsequence. After that, we return the maximum number inside the DP array, which is gonna be the length of the longest increasing subsequence inside the input list. So for the space complexity, we have O of n because we're creating a new array with the same length of the input array. For the time complexity, it's going to be O of n squared because we are iterating throughout the input list once, and at each number inside the list, we are iterating at all the numbers that comes before. So guys, I hope you have a clear understanding of how you can solve it using dynamic programming. It's a medium question. If the interviewer asks you to solve it using dynamic programming, it's going to be a little bit easy. But for reducing the time complexity or space complexity, it's going to be a tough problem. So I'm going to show you in the next video how to solve it by reducing the time complexity, or if the interviewer asks you to reduce the space complexity also. See you in the next video. Thanks for watching.